working. PowerPoint presentation. Oh, great. Okay, so this is Chapter 3, Central Tendency. Looks like very exciting there. Now that I see the presentation, let's start with the overview. So, central tendency, what does that mean? We're trying to find one number, one score that represents a sample or a population in a summary kind of way. Okay, so we have three options. Mean, which is basically you sum the numbers associated with each of your sample. Those are called scores or data. And then you divide by the total number of the sample. There's the median. This is meant to represent the middle. So it could be the middle number, or it could be the 50th percentile. So usually middle number, that's going to be a whole number, or at least one of the numbers that you actually had in your sample. And the 50th percentile, that could be a number that isn't actually one of the numbers that you measured in your sample. So both mean and median, if you think about it, they're both measures of a center, right? Center here, somehow the center number, the sort of equal distance between all the numbers to this mean number. And this, as opposed to being equal distance, it's more the middle percent, or the one lying in the middle, the number lying in the middle. And we have a third measure of central tendency, which is called mode, which is just basically the most popular of all of your data options, right? So the most common number, for example, in our sample up here is 1. Okay, let's talk about the mean. There's two ways to think about the mean that I know of, including equal share and balance point. So we're going to talk about equal share. So you can see over here what I did was, instead of having just a circle representing each score that you had, I put a number of boxes that corresponds to the number of the score that each one of those sample members had. Now the first thing that you do to calculate the mean is you sum everything together, you just lump it together. So you pretend that all of these scores did not have any individuality, and you lump them together. And of course, you can think about it in a kind of funny way. You're sort of taking from everybody what they have. And then when we calculate the mean, we basically divide that sum total into equal parts. The book, yes, refers to it as, I think, communist kind of concept. So, so now you see here, it's the same amount in total, but now each member that you had initially gets an equal amount, which in this case turns out to be 1 2/3. Let's talk about the mean in terms of a balance point. So you can go back to thinking that everybody's got an equal share, but what they do is they sit on a little teeter-totter on the number line at the point that corresponds to their score. So the question is, if they do that, where is the balance point? You can try different points, and you can see why they do or don't work. So for example, if I chose this balance point, I'm going to say that's at about 2.3. What you do is you take the distances from each of the scores, and you add them together, basically, to find out the distance on the left versus the distance on the right. So on the left, we have 3 distances of 1 1/3, plus 2 distances of just 1/3. And then on the right, we have a distance of 0.6, or 2/3. And so in that case, the distances on the left are not equal to the distances on the right. And so we don't have a balance point. Here's an option on the other side. Now we're directly under the numbers 1. So now if you try to calculate the distances, you see that there's really 0 distances on the left of that balance point, and to the right you have distances of 1. You have 2 distances of 1, and then 1 distances of 2. And again, you want to imagine this as these are sort of weights, equal weights at these points. So the total distance on the right is 4, and the distance on the left is 0, so those are not equal, so we don't have a balance point. So here's the actual balance point. Now you can see that the distances on the left, right, you have 2/3, 0.6, 2/3, 2/3. 3 times 2/3 is the distances on the left here, and then on the right you have 2 distances of 1/3 and 1 distance of 1 1/3. If you sum all of those on either side, you get a total distance of 3 on either side. And so that's how you think about the mean as a balance point. Now let's talk about the median. Median is simply the middle number, and also can be thought of as the 50th percentile. We'll talk about each of those styles of thinking individually. So if you want to think about it as the middle number, you have to order the numbers first, small to big, and then you find the middle number, and that's, if you just find the middle number, that is your median in this way of calculating the median. If you have 2 numbers in the middle, you have an even sample, then you have to find the middle 2 numbers and average them. So in this case, we have the numbers 1 and 2, and of course the average of 1 and 2 is 1.5. Now let's talk about the median as the 50th percentile. So remember we talked about percentiles and percentile ranks. Basically, percentile tells us what percent of our distribution have we gotten to at what point. So you can see there's a total of 6 scores, and by the time we pass our 1 category here, we've gotten to 50% of our scores. We have 3 out of 6. And then when we add 2 more, we've gotten to 83.3%. And when we got to the total, we got to 100% of all our scores. So that's basically what the percentile tells us. Now, we want to find the 50th percentile in this distribution. So the question is, what is that number? So first of all, you want to ask yourself, just to be clear, 50% right now, it's not always going to be this case, but now we have an upper real limit coinciding with 50%. And so 50% is at the upper real limit of the 1 category, okay? Now, how would you then figure out what the median is? Now, my initial thought would be the median would be 1, right? Because we're at the 50th percentile by the time we get to the top of the 1 category. But let's think about it as if this were continuous data. If this were continuous data, then each of these categories has certain real limits. So the median is 1.5, because the real limits of the 1 category stem from 0.5 to 1.5, and the 2 category goes from 1.5 to 2.5, and so forth. So the median in this case is 1.5, and that actually coincides with the number that we got when we calculated it the other way, but you're not always going to get the same number when you calculate them, those different ways. Okay, let's talk about the mode. Mode, just the most common number. When you look at a distribution, it's going to see where the peak is in the distribution. I didn't provide a graph of that here, but if we go back to our previous slide, you can see what the mode is clearly represented by the highest peak in the distribution here. So our mode is 1, as seen here. And then we can see it here by highlighting the most common number. Think about it as a populous thing, the most popular thing. And that's why that's a good measure to use for central tendency when you have some sort of nominal scale, it just sort of names of things. So here's a little summary of when to use which type of central tendency. Mean is the most common measure of central tendency. It's nice because you can do calculations It's a numerical measurement, and it's actually related to these two values, standard deviation and variance, which we'll talk about later. You need to know the mean to calculate those two values, so that's why we say they're related. The median, you want to use the median in cases where you have extreme scores. So if I have a score way out here or a score way out here, it doesn't affect the median that much because we're just going score by score by score or percentiles by percentiles. So those extreme scores aren't going to affect the value of the median that much. That is the same kind of thinking that rationalizes why we do that for skewed, use the median for skewed distributions. Other situations where you want to use the median is if the mean, you just can't calculate it because, for example, you have undetermined values. So examples from the text might be you gave someone a task to complete, you record the number of minutes, but then there's a certain amount of people who just didn't even finish the task. So you're going to use that as a category that has some rank order in terms of the other categories. Maybe you have 1 minute, 2 minute, 3 minute, 4 minute, and then not completed. You still want to include those data from the people who didn't complete the task. So you wouldn't be able to calculate a mean because they don't have a numerical value, but you could calculate a median. And that's a similar idea with open-ended scales. And ordinal scales like small, medium, large, you could clearly say like the favorite of these is large, and the median sort of makes sense because it's sequential, and we can think about it as you get to 50% of the distribution by the time you get to a certain size or score that's just corresponding to a rank. And then mode, what's left for that? The nominal scale variables, like what kind of car do you drive, what's your major in school, and you also can use the mode when you're looking at discrete variables. So for example, number of children, you don't want to report a median of 1.2 children because nobody has 1.2 children, so you're just going to pick the most common value. So now we just want to look at how these three different values may be distributed when we look at different distributions. So if you have a symmetrical distribution, the mean, the median, the mode tend to be the same value. If you have a skewed distribution, it tends to be the case that the mode, is more towards the peak of that distribution. The median comes a little bit to the side of the tail of the distribution, and then finally the mean goes farthest towards the tail. And this is just another example which just goes in the opposite direction. Mode, median, mean tend to follow that sequence. If you had a bimodal distribution, this may not be the case, but in these general unimodal distributions where you only have one peak, this is pretty common. Okay, I just want to talk about how to write about and report when you have mean values. So the first thing you want to think is you want to make a general sentence, but put the specifics in the parentheses. So I found that men scored higher on this exam than women, and in a very general way. Okay, and when you say higher, after that you put in parentheses mean, letter M in italics equals whatever the mean is, and then after you say than women, then you can put it in parentheses mean equals whatever their score was, their mean score. You can look over this information in the chapter. The median can be reported using the abbreviation MDN, and you can also report either of these statistics within the text. So the median number of errors for the treatment group was 8.5. You could just say what it was without using that symbol, MDN or M.